All right, today we are starting our new unit over polynomials. So today we're going to talk about how to classify polynomials, which will be a lot of vocab, and then also how to add and subtract polynomials, which for the most part you've been exposed to before when we combine like terms. We're just continuing to combine like terms, and we'll talk about how it looks just slightly different in a polynomial. So our title for today is classifying polynomials, and then you have a couple of definitions here if you'd like to pause and write them. So a polynomial is an expression of more than two algebraic terms. And really it could just be one term as well. We call that a monomial. But poly suggests that there's more than one, so that's why we're writing more than two, especially the sum of several that contain different powers of the same variables. A term is a number, a variable, or a product of both separated by addition and subtraction. So, for example, if I had something like this, x squared plus 2x plus 3, this would have 1, 2, 3 terms, and this whole thing would be considered a polynomial. Okay, so again, feel free to pause if you need time to write this down and or catch up. Standard form. So standard form means that we are writing these polynomials in order from largest exponent to smallest. So you want to write each term in order from greatest to least degree, which is referencing the exponents. The leading coefficient is the first coefficient after it's written in standard form. So here we would have, this is my largest exponent, so I want y to the 5th first. Then this is my next one, so plus y to the 3rd plus 4y. So now it's in order from greatest to least, and my leading coefficient, since there's not a number here, is a 1. So another example, again, we're doing least or greatest to least by exponent. So this is my largest exponent here, this negative 4x to the 3rd, and we want this minus goes with the 4x3. It goes with whatever's behind us. So when we move it, we want to bring that negative with us. And then we have negative x squared. Then we would have 20x. Since it's positive, it'll be plus. And then we'll have our plus 2. And then our leading coefficient here is negative 4, the very first one. Okay, so that's standard form. Write it in greatest to least by exponent. We can name polynomials in two ways, by degree and number of terms, and usually they'll ask us for both. So number of terms, if there's just one term, that's a monomial. 2 is a binomial, 3 is a trinomial, and honestly, binomials and trinomials are going to be what we work with the most in this unit. And then anything larger, 4 and up, we'll just call a polynomial. Poly stands for many, tri is 3, bi is 2, mono is 1. So they're words you've seen or prefixes you've seen before, but that's how we would name polynomials. By degree, which is its highest exponent. If the highest exponent is 0, it's a constant. If the highest exponent is 1, it's linear, and we spent a ton of time on linear equations where we had y equals mx plus b. That's because our highest exponent was a 1 in that kind of equation. 2 is quadratic, which will be our last unit of the year. We'll spend a whole unit just on quadratics. And then cubic, quartic, anything 5 and up, we would just say 5th degree, 6th degree, and so on. And really, you could probably even start that at 4. These are the, from constant to cubic are the ones you should know the nicknames for. But after that, we're fine if you do 4th, 5th, 6th degree. Right, so here's some practice. We are going to name these by number of terms and by degree. So if I was going to rewrite this in standard form, which is always good practice, I would have negative 18 x to the 5th plus 4x. So that's it in standard form. My leading coefficient would be negative 18. Now if I wanted to name this, it has 2 terms. It's separated by addition or subtraction. So 2 terms, that makes it a binomial. And then its highest degree is 5, so we would say to the 5th degree. All right. This one's already in standard form because you have your highest to your least exponent. This would be 3 terms, so we would call it a trinomial. And then when you have more than one variable, you really need to add these together. So if I have an exponent of 2 and an exponent of 1, that means that this is really a power of 3, and we would call it a cubic trinomial, or trinomial that's cubic. That can really go either way. Sometimes cubic trinomial sounds better, but when you have more than one variable, you want to add their exponents together, kind of like we were doing in exponent rules. So since they're not like terms, we can't really add them together to simplify them, but in terms of identifying what degree they have, we do want to add them together. All right, last one for this page. We have already in standard form, that's great. And this time we have 4 terms, so that'd be a polynomial. And then our largest exponent is 4, so we could call that quartic, or even 4th degree is fine. I just want to make sure you know from 0 to 3 the most, and then after that you can start saying 4th degree, 5th degree. But technically this would be a quartic. And this one is technically a quintic, but again, we just want you to know up through cubic. Combine like terms. So this is where we're going to talk about adding and subtracting these polynomials. And like terms in the situation of polynomials are terms that have the same base taken to the same degree. So x squared is only a like term with other x squareds. X's are only like terms with other x's. So you're not just looking at the variable this time, you're also looking at its exponent. So here when I have 4x squared and 2x squared, 4x squared plus 2x squared would give me 6x squared. And sometimes since these can be long, I think it's helpful to mark them off as you go. Or here we have 6x plus negative 9x, that would be negative 3x. And they're not always in order. So again, I would suggest you mark them off as you go. And then 7 plus 1 is 8. So this would be our simplified version. Here's another addition. So I have 4a to the 5th plus 3a to the 5th is 7a to the 5th. Then, and then I have this one minus 7a to the 5th. So 7a to the 5th minus 7a to the 5th is actually 0a to the 5th. And if there's 0 in your final answer, you don't need to write it. So we don't need to write 0a to the 5th, it's just gone. So really these totaled to be 0. And then here I have 8a plus 6a would be 14a. And 14a plus 1 more a is a total of 15a. Again, I would cross them off as you go so that you don't skip one. Similar idea, but this time it's subtraction. And sometimes with subtraction, it is easier to do where you're changing every sign. So minus 2x squared plus 9x minus 1, because sometimes then you forget that when you're subtracting a negative, you're really adding. And when you're subtracting a positive, that's easier, but these double negatives sometimes get students. So really what you can do is distribute that negative, and now you have an addition problem, which usually there's just less errors overall. If you do that, you're just changing every single sign. So 4x squared plus negative 2x squared is positive 2x squared, or if you like to leave it as subtraction, 4 minus 2 is what you're doing there. Here we're doing 6 minus negative 9, which is the same as 6 plus 9 is 15x. And then you have 7 plus negative 1 is 6, or if you like to leave it as subtraction, you have 7 minus 1. So here, a to the 4th minus 3a to the 4th is negative 2a to the 4th. Negative 2 minus negative 3a. Again, sometimes that double negative is tricky. Remember, you can add the opposite, so that is going to be a positive 1a. And then you just have minus 1, so a negative 1. All right, one more, a word problem today. A penny is thrown straight from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represents the height in feet of the objects after t seconds. So this would be our penny, and this would be our paintbrush. This -16 coefficient that you're going to see a lot in these types of word problems is due to gravity. So that's why it's going to be, you're going to see -16 a lot. It doesn't change a lot because this would be gravity in feet per second. I think you've seen in science before that gravity is like -9.82, I want to say, meters per second. So if we convert that to feet, it ends up being -16 a lot. And then it says, write a polynomial that represents the distance between the penny and the paintbrush. So that means I want to find the difference between these two polynomials, or that I would have to subtract them. So -16t squared minus -16t squared is going to be 0. And I don't need to write that in my final answer if it's 0. And then I have -40t, that's the only one. And then I have 200 minus 100 is 100. So this would be my answer for part A. It says interpret the coefficients of the polynomial in part A. So here we have -40t. And it says coefficients. So that, I think that just means this -40 because 100 is a constant. But -40, t stands for seconds, so you're going down 40 feet per second. And if they wanted us to interpret this 100, it means that there's 100 distance in starting. Like this one started at 200, this one started at 100. The difference in the initial start distance was 100. But that -40 would be that it's going down 40 feet per second, and since that would be essentially our slope. All right, that's it for your notes today, and then you are working on a book assignment.